The first part of today's lesson is talking about factors that affect solubility. So first of all, solubility is how well something dissolves. And there's several things that can affect how well something dissolves. And usually we talk about dissolving in water, but it doesn't have to be. You can have different solvents. The first thing you want to look at is polarity. So polar things can dissolve polar things, nonpolar can dissolve nonpolar, but usually polar and nonpolar have trouble dissolving into each other. So if you're talking about water, water is a polar substance, so it's easier to dissolve other polar substances into water. The next thing you want to talk about is pressure effects if you're talking about dissolving gases, specifically in gases in a solution. So this would be something like carbonated water. You have to dissolve the carbon dioxide into the water, and the only way to get it to go into the water is it's like you're pushing on the gas to force it to go into the water. So it has to be under pressure, which is why when you pop the top off of a soda can or something that's carbonated, you hear that hissing sound. That's the effervescence, which is the rapid escape of a gas from a liquid. So you can use this equation, it's called Henry's law, to show the concentration and the pressure. So if you want a lot of carbonation in your liquid, you're going to have to push on it more to get that carbonation into the liquid, or whatever gas it is. So you can see it's a direct relationship. The more pressure you apply, the more concentrated you can make it. So P stands for the partial pressure of the gas, C is the concentration of the dissolved gas, and then K is a constant that has to do with which solutions you're using. So that means it depends on the actual solute itself. So most of the time they would give you K for this and then either give you the pressure or the concentration, and then you just have to solve for the other one. And make a note that it works best for dilute solutions of gases, especially if the gases do not react with the solvent, and also if they don't dissociate. So you want the gas to stay as the original compound. Temperature is confusing because solids and gases do two different things. So solids would be like dissolving sugar into tea. So if you want to dissolve a lot of sugar into your sweet tea, you can actually dissolve more sugar into the tea if you have hot tea. So usually temperature, the hotter it is, the more solid you can dissolve into the solution. Note that it always occurs more rapidly. So there's two things you can look at: how much you can dissolve and how fast it dissolves. So increasing the temperature will always make it dissolve faster. It also, if it's a solid, usually means you can dissolve more of it into the solution. For gases, it's the opposite. So when you think about your carbonated soda, the colder it is, the more carbonated it can be. So that's the opposite. The colder the temperature, the lower the temperature, the more carbonated you can have it. We've used this equation before. If you're doing dilutions for these solutions, remember you use M1B1 equals M2B2. The next thing has to do with something called a colloid. And a colloid is kind of like the middle for solutions. So you have a homogeneous solution, which has really tiny particles that are so small that you can't even see them, and they just float up in the solution. A suspension has really big particles that are so big that if you leave it sitting for a while, the particles will settle to the bottom. So that would be something like muddy water. If you let muddy water sit there, eventually the particles will sink to the bottom. Colloids are kind of in the middle. So the particles are small enough that they can float throughout the solution. They're not going to sink to the bottom. But the particles are bigger than homogeneous solutions because they can do something that the other solutions cannot, and that is to reflect light. So this is called the Tyndall effect. And you heard about this if you've taken driver's ed, which most of you have. So they talk about the Tyndall effect when they talk about not putting your bright beams on during really foggy weather. Because the fog, the particles are big enough in the fog to reflect light. So if you put your bright beams on, you have enough light reflecting off the fog to kind of make it hard for you to see. It's like it blinds you. So they tell you don't put your bright lights on when it's really foggy conditions. And that has to do with the Tyndall effect. So it's the scattering of light by particles. And the most common example of a colloid that I usually hear of is milk. So milk has bigger particles than most homogeneous solutions. They're not big enough to sink to the bottom, so it's not like it separates out in the refrigerator. But if you take a flashlight and shine it into milk, it looks like the milk is glowing, and that's because the particles are big enough to reflect the light. And here's a bunch of examples if you're curious about some other colloids. All right, the last thing for today are these solubility curves. So this is a curve that shows how much stuff you can dissolve into water. But several things matter. There's several factors you have to take into consideration. One is the temperature, because I just told you that for solids, the hotter it is, the more you can dissolve. So notice that most of these lines have a positive slope, which means most of them are solids. There are a few, like NH3 right here, that has a negative slope, and that's because it's a gas. So remember, gas is the colder the temperature, the more you can dissolve, so they're going to have a negative slope. So the positive and negative is dependent on what state of matter it is. The other thing besides temperature that you have to keep in mind is how much water you have. So 1 drop of water versus a gallon of water, you're going to be able to dissolve different amounts of solute in different amounts of water, right? So a gallon is going to dissolve more stuff than a drop. So what they did is they set the grams of solute or grams of solvent of the water at 100 grams. So what this graph is showing, the y-axis is the grams of stuff, the grams of solute, that you can dissolve into water if you have exactly 100 grams of water. And you can see what temperatures you can do. So you can compare how much stuff compared to the temperature. There's a few words up here you want to be familiar with. Saturated has to do with the maximum amount of solute that's dissolved. Unsaturated means you don't have the maximum. And then usually when you have a saturated solution, like let's say you like your tea really sweet, so you dissolve as much sugar as you can. Once it becomes saturated, if you add more sugar, the sugar will just sink to the bottom. It won't actually dissolve into the tea. However, there's a way you can make a supersaturated solution where you have more than the maximum, and that's by, it's kind of a complicated process, but you have to heat it so it gets really hot and you can dissolve a lot in it. And then if you cool it really slowly and you don't bump it to start the crystallization, you can force it to have more than it's supposed to have. That doesn't happen very often, but just realize that supersaturated can actually happen. So if you find a point on this graph that's on a line, so for example, if you have exactly this temperature and 90 grams, that is a saturated solution of sodium nitrate. So on the line is showing exactly how much you would have to have at that temperature to make a saturated solution. If I give you information, like if I say that we're at 40 degrees and 80 grams of NaNO3, that is unsaturated, because at 40 degrees, you could dissolve 105 grams and you only have 80 grams dissolved. So we say that's unsaturated. So if it's under the line, it's unsaturated. If it's on the line, it's saturated. And above the line would be supersaturated. And then you just have to be careful with these questions to make sure that you check the amount of water. So let's look at the first one. It says, how many grams of KClO3 can be dissolved in 100 grams of water? That's what the graph is showing, is 100 grams of water, so we're good on that, at 50 degrees Celsius. But we're not going to use that 100 grams. That just means we can use this graph because this is also per 100 grams. So what we're going to focus on is the temperature. So we're going to go to 50 degrees. We're going to go up to the KClO3 line, which is right here, and then follow it over to the left, and you should see that it's about 20 grams. The next one says, at what temperature could you dissolve 70 grams of ammonium chloride in 100 grams of water? So again, we're at 100 grams, so that means that we can use the graph. This time they're giving us information about the y-axis because it's in grams. So we're going to go up to 70 grams, and we're talking about NH4Cl, so we're going to go all the way over till we get to NH4Cl, which is right here. So that's going to be about 90 degrees Celsius. It says, which compound is most soluble? Most soluble means you can dissolve the most grams of it, so that would be the highest towards the top. So if you go to 10 degrees and go all the way up, Ki is the most soluble. How much NH3 could you dissolve in 500 grams of water at 90 degrees Celsius? So first we're going to go over to 90 degrees Celsius. And we're going to go up to NH3 because that's the one they're talking about. And then we're going to follow it over and we see that it's about 10 grams. But that 10 grams is if you have 100 grams of water. So since they made it 500 grams, we are going to multiply our grams by 5. So 10 grams is if it's 100, it's like a ratio. So in 500 grams, we can have 50 grams. The next one says, what kind of solution could you have if you dissolved 160 grams of KNO3 in 200 grams of water at 60 degrees Celsius? So first of all, we're going to divide both of those by 2 so that we can use this graph. So 160 grams in 200 grams of water is the same as saying 80 grams in 100 grams of water. So now we can use the graph, and we're going to focus on 80 grams at 60 degrees Celsius. So let's find that point. Here's 60, here's 80, so it's going to be this point right here. And we're talking about KNO3, which is this chemical. So notice that my green dot is under the KNO3 line, which is why it's unsaturated. Number 6 says how much precipitate would settle out. So first you have to know that word precipitate. Precipitate means a solid that's formed from two liquids. So if you have something dissolved and the stuff that's dissolved is no longer dissolved and it comes out and sinks to the bottom, that's what a precipitate. It's one way that you can make a precipitate. So let's look at NH4Cl. And we are starting at 90 degrees and we're going to 70 degrees. So NH4Cl 90 is here, and 70 is here. And so if you look at the difference between those, the difference is 10 grams. And so 10 grams would settle out of the solution. And that's it for the lesson today.